equilibrium of a particle in 2D space, two-dimensional space, right? For now, we'll look at two-dimensional space, just X, Y, and then we'll get into three-dimensional space later on. Talk about vectors in 3D and how can we deal with particles in three-dimensional space. Now, remember I said when we want to study objects in this course, the name says it all, like it's a statics, right? Everything is in a static equilibrium. So briefly, I want to say a particle is in equilibrium if it it stays at rest provided that it was originally at rest or has a constant, let's say, velocity. Let's say velocity if originally at motion. So we say pretty much following the first law, Newton's first law, right? If it's moving, it should have a constant velocity. If it's at rest, it should stay in rest. Now, that is when we call a particle, or later on we'll say rigid body, an object is in equilibrium. Now, we specifically talk about the static equilibrium in this course a lot. And it's used when the object we're trying to study is at rest. Right? So equilibrium can either be at rest or be moving in constant velocity. But we use the term static equilibrium specifically, or better to say, to describe an object or particle at rest. So if it's at rest, static equilibrium. But general word, equilibrium means it can be at rest or can be moving with a constant velocity. Newton's first law. So if an object is in equilibrium, meaning that is at rest or is moving with a constant velocity on a straight line, first law says the vector sum of all the forces applied to that object should be zero. First law from Newton's first law, summation of all the forces, which forces are vectors, is equal to zero. This is the most fundamental relationship we're going to work with in this course. All right, you see this a lot. This is basically, they refer to this as equation of equilibrium. Equation of equilibrium. Meaning that this equation describes an object, a particle, a rigid body, which is in equilibrium. Now remember, this is a vector sum. All right, this is a vector sum, meaning that all the forces, you have to take into account the direction as well. These are vectors, F. So vector sum of all the forces acting on an object. All right.